Hello, today we are going to talk about what the body does to drugs after you take them. Drugs have to get to the brain. That's the only way can to make somebody feel different, and it's the only way to get huge. For drugs to get in the brain, they have to be in the blood, and various factors determine how much drugs get into the blood and the brain, and how long to they remain there. Overall, what happens to drugs in the body is referred to as drug dynamics. The first thing that happens, and after you take a drug orally, is that it has to absorb it from the stomach and the intestines into the blood. From the blood it passes into the brain, and again, all of the drugs have to get in. Allows the drugs to get the brain to have an effect. A large fraction of the blood pumped from the heart goes directly to the brain. Drugs inject directly into the bloodstream and not absorbed by the stomach, but still passed into the brain. Some drugs, such as nicotine or inhalants, are absorbed directly from the air in the lungs into the blood. Different drugs have different absorbance efficiency. Some drugs are nearly all absorbed and not others are not. The next step is the drugs are metabolized or changed. The metabolism of chemical modification of the drugs can result in the cessation of the actions, and metabolism can also enhance to the step which is the aggression. Drug metabolism usually takes place in the liver, but it can take place in other bodily organs as well. It's the enzymes in the liver and else where that modifies the structures of drugs. An example is the metabolism of ethanol. Ethanol or alcohol is acted upon by an enzyme called ethanol, and all the enzymes for aldehyde, which in their changes fuse into acetate into active substance. For a metabolite of ethanol is the active, and the effects of taking ethanol or alcohol is determined by its metabolism. His next example shows as many possible metabolites of nicotine. You can see the extraordinarily complicated and many different kinds of metabolites of chemical structures are possible. For of course, you don't have to remember all of his, and shows you this just to give you an impression of how complicated drugs metabolism can be. In the next and final step in the drugs journey in the body is drugs elimination. Drugs are their metabolites and removed from the body, mainly in the phases. A couple of important concepts related to drugs elimination includes clearance, which means the body effects eliminating to the drug, and the second is elimination half-life. The half-life of a drug is measured to the rate removal of drug in the time needed to remove or metabolize 50% of half of the drug. So we have discussed three main steps: drug absorption, drug metabolism, and drug elimination. His drug deals with the idea of half-life. It shows with the differences into different substances A and B from the blood, and they have different half-lives. Drug A has a shorter half-life and drug B has a half-life twice of that of A. A. When we look at the levels of the drugs in the blood in the solid lines, you can see that on the curve falls to zero much faster than the other. And that means that the drug A has a shorter half-life. In the half-life is shorter, then the drug disappears faster. Normally of 97% of the drugs to be eliminated from the body. It will take 5 half-lives. But if drugs is taken orally, then the drug has to be absorbed first. It builds up slowly in the blood, which is the dotted lines in his image. After it builds up to its peak, it is then eliminated at a rate according to its half-life. Its half-life pointing at the known drugs and metabolized is the fraction. Ethanol, for example, is metabolized at a steady rate rather than a fraction rate. Now introduced to the topics for the night on the fractional effects of the drugs being excreted into the urine, that the many drug screens and the tests have been developed to screen for the presence of drugs in the urine.